In this video, I'm going to show you how to use Esri shapefile with ipyleaflet. In the last video, I already showed you how to use GeoJSON with ipyleaflet, and because shapefile is one of the very commonly used GS data format, and I'm also going to show you how to actually add the data a GS shapefile to the map, and so they can use it to do interactive mapping. And so in this video, I'm going to show you like a step-by-step how to build up the package so that we can add additional functions to the package. And so user essentially just need one line of code, and then they can add data to the map. Okay, and so you can go to my GitHub repository, GeoDemo, and I already did some coding. So the code is actually within the develop branch. So if I click this one and then navigate to the GeoDemo, if you click inside, you should be able to see the source code that I added. So, and last time we actually added this one. So this is the portion that we already completed in the last video, add GeoJSON. And I also show you how to use a Jupyter Notebook example to test the function. And so in this video, I'm going to just add this another two functions to the map so that you can add a shapefile easily to the map. The idea is that because ipyleaflet can only work with a GeoJSON, okay, it cannot directly display a shapefile. So what we need to do is to convert a shapefile to GeoJSON and then add GeoJSON to the map, right? So the critical part here is to figure out how to convert a shapefile to GeoJSON. And in this video, we are going to use a Python package called pyshape, pyshape. You can just do a Google search and then pyshape GitHub. The first link, you should click the link, and you should be able to see this package in here. So this is the one that can use to read and write Esri shapefiles in Python. So, and we need to basically install this package to our Conda environment. You can scroll down, you can take a look the installation example. It's probably somewhere towards the end, but as long as you know the name, usually it's just pip install. So let me scroll up here, see if we can find the installation and how to we changes. Let me see here. It's not here, but you can also go to, let me show you the other way. Go to the PyPI and you click the first link. You should also be able to find the package, and very much pretty much the same, but usually this is what we need to do, pip install pyshape, and you can just copy the link. So next I'm going to open an Conda prompt, then we can Conda activate demo. So this is the Conda environment that we have been using for this tutorial series. And so next we're going to, you can just type conda list if you want. It's going to show you all the Python packages that have been installed in this environment, and you can use pip or you can use conda. So you can use conda, and for this one I'm just going to use pip. You're welcome to use conda if you want, and it's going to take just a few seconds. So this package has been successfully installed. Now you can just type conda list again, then try to scroll to find the pyshape 2.1.3. It has been successfully installed. So next, let's open Visual Studio Code and then start doing coding. Keep that in mind. This is right now the package is very simple. It doesn't have multiple modules. So right now we only have one geodemo.py, and within the module we have one class called map, and this map inherits ipyleaflet. So basically all the functions and properties of the ipyleaflet map class, we can use this one, but we also add some additional functionalities. Let me collapse this one just to show you the differences. So the function that we add in the last video, add GeoJSON. So this function belongs to the map class. That basically means when the user create a map, and then for example, if the variable is named m, then the user can just use m.add GeoJSON, right? So anything, if you see the indentation label here, def means define a function. So if it is indented, that means everything here belongs to this class. Okay, so in this video, I'm going to show you actually we want to add a function outside this class, so it becomes independent. The reason why we want to do this one is that, for example, if we're trying to convert a shapefile to GeoJSON, it has nothing to do with the map. Okay, so it can be just a command line. So in this case, it's better to have the function outside without having to rely on the map, because data conversion does not need to have an interface. Okay, it can just be a command line. So what we need to do here is actually to enter, and then usually within the module here, if we want to have a function, you can use it to empty spaces, to empty lines, and then use backspace to go to the top. So what we are trying to do here is that if something is has nothing to do with the class, they need to be to the top level. So there's no indentation needed. So in this case, we are just going to create a new function, and then just type def. You can also maybe uncheck this one. Let's just show you the hierarchy, right? So in here, let me close this one. Right, so this function here, def, is different from the other two functions. Those two functions belong to the map class. The new function we are going to create, it has nothing to do with the map. So we can call the function, for example, ssp to GeoJSON. Okay, so, and this is what we are trying to, the function we are trying to create, and then comma, right? So think about that. Whenever you are writing a function, you need to think about to conceptualize what parameter you want the user to provide. And keep in mind, so you want to convert a shapefile to GeoJSON. So always in the function, you need to think about what's the input, what's the output. Okay, so the input, there might be some required parameters that the user must provide, and there will also be some optional parameters that you can, if the user don't provide, you can just use the default one. But there will also be output. So in this case, shapefile to GeoJSON. So definitely the user need to provide a shapefile, right? So you need to have the input. That one is basically a required parameter, and the output is a GeoJSON. So there are two ways you can do this. So the first one is to ask the user to provide the file path to the GeoJSON that the user want to create. You can also just use the GeoJSON as a temporary, so it's going to be as a dictionary. So GeoJSON actually is a dictionary. If you want to see what it looks like, you can go to my repo. You can also go to the GitHub. Let me show you here the geodemo, and then go to geodemo examples data, right? So from here, if you see some of the GeoJSON, they say US states GeoJSON. If you click, this is GitHub actually can render the GeoJSON on the map, right? So and in the previous video, actually we did this just to load the GeoJSON to the map. You can also click the raw button. So from the raw button, you should be able to see this one here. It's basically a very long string, and then within the string, you have some different keys and also values. So basically, you see all the coordinates. So those are basically the values, and it's a feature collection. So features, and these are all the coordinates for each individual polygon. As you can see, this is a GeoJSON, but it's a dictionary that can be written as a dictionary. So the user actually does not really have to export to a physical GeoJSON file. They can be basically written as a dictionary. So then you can use the dictionary to continue to add the data to the map. And let's go back to the Visual Studio Code. So next, I'm going to show you how to add this function here. To save some time, I'm just going to copy the function from GitHub, and let me go back to here and switch to the develop module, and then go to geodemo, this one. I'm just going to copy the source code here to save us some time. Copy, and come back to here, and then put your code at the beginning, save, and then Control S. As you can see from this one here, we are going to use the shapefile and also import JSON. So those are the two libraries that we need. One key step here is that if you add any additional dependencies to your package, you need to add that one to the requirements.txt. So first we need to double click this one, in the previous videos, I show you how to use a Folium and ipyleaflet. So we already have these two, but we also need the new one that we add. So it'll be py-shape. The reason for this is that when the user install the package, it's going to install all the dependencies within this requirements.txt. So make sure that if you add any additional package, you always need to come here to add this. Otherwise, the user won't be able to actually use the functions because they are going to run into errors. So once you have the requirements, and then you can import the library, the JSON, and also the shapefile. So the JSON, this one is the built-in Python library module, so you don't need to actually to install. We can use it directly. And so within the shape to GeoJSON, right, we also need to look at what's the input, what's the output. And I'm going to just copy this one here in shape and out GeoJSON, and come back to here and just paste this one. So this function, we have two parameters. The first one is in shape, and the other one is output GeoJSON. So we set that one the default values to none. That means the user does not is not required to provide this one. They can just provide the input shapefile, and then we are going to return. If the user does not provide the output JSON, we are going to return as a GeoJSON dictionary. If the user does provide this one, we're going to create a GeoJSON file. So this goes through the source code here line by line. The first one here is in shape. So this one we're just going to convert to an absolute file path, because sometimes on different computers, sometimes the relative file path might cause some issues. So it's a good practice to actually convert from relative file path to absolute. So using the OS module, .path.abs. abs means the absolute file path. If you want to, for example, let me open Jupyter Notebook and to show you like what's the differences if you have not used this before. So notebook, and then we can go to the repo here, geodemo examples, and I can open the one that we used in the last video. So I can maybe in here I just import OS, right? Shift enter. If you see from this one here, like in GeoJSON, for example, let me execute this one, create a map, and then in GeoJSON, if you see from this one, this is a relative path, because on Windows you don't see the C or D drive or E drive, and it's always a good practice to convert this one to an absolute file path. If you want, I can just os.path. Right, abs path, and then you can pass in the in GeoJSON, alt enter. Now you can take a look. So this one is actually the full path based on what you provide in here, and it's converted to the Windows file path, and with also double backslash, also the C drive. So what we want is this one. So once it convert to absolute file path, then we can take a look at the source code, the next line. If the file provided does not exist, so os.path exists is to check whether the file exists or not. So if it doesn't exist, then the opposite. So it doesn't exist, that means it's true. And then if it's true, not true, that means false. If it is false, then it's going to raise an error saying that, oh, the file could not be found. So in this way, it will stop here. Otherwise, if you don't check this one, it's going to continue. So it's going to cause trouble. So it's always better to basically raise some issues early on without having to go into other source code. So if the file can be found, so that means it exists. That means it will not be executed. So that means we can continue. So once the shapefile, if we valid and then it is there, then we use the shapefile, this package, to read the file. So shapefile.reader, and then pass in the file path, then you will get a special SS shapefile. Within the shapefile, there is a function called GeoInterface, and then so this one actually is you converting this one to a GeoJSON. So as simple as that. If you really want to test this one, we can certainly do it. So let me show you in here. Sometimes if you can actually test this one using Visual Studio Code, but because this is the function, it's not being executed until the function is being called on somewhere. And if you want to test it, for example, directly in here, you can. So maybe you can define another variable called inswap, okay, equal to double quotes, and then dot means the current directory. As we know that the current directory, and then the data, if you hit tab, and then for example countries, right? So we'll be able to find out the shapefile here for all the countries in the world. So this one right now, this is the file path, right? So how can we figure out how can we actually convert this one to a GeoJSON? If you go back to the source code here, this is the 2 lines that's essential, okay? So these 2 lines, and if you come back to notebook, I can paste in here. Keep in mind, you need to import the shapefile because we didn't do that earlier. So I can just do it in here, import shapefile, and then shift enter. Right, so then you can just print out the GeoJSON, and you can just GeoJSON, alt enter. You should be able to see the file, right? So right now this one basically is being loaded as a dictionary. So this is a Python dictionary. In the last video, I actually show you how you can use this one to add the data to the map. So if you see, this is the GeoJSON. So let me show you this function in here, right? So this is the function that we used last time to add a GeoJSON file to the map. Right now the map here is empty. We don't really have anything. So if this is the GeoJSON that can be returned, that means we can just use m.add GeoJSON, right? Parentheses. So the first one we need to pass in is the input JSON, right? So it comes from here. It's actually this one, right? So we just need to copy this one, paste in here. We don't need the style, but we want to provide a layer name, and then maybe the equal to GeoJSON, and alt enter. Now we go back to the map. Okay, it has been added. So this is how you can test the function before in Jupyter Notebook, and because it has the user interface, and then you can take a look at the source code and also see the input and output interactively. Once you take a quick testing, you think it's feasible, then you can go back to add the data to the to finish the function in Visual Studio Code, right? So let's go back to here, and let's take a look at this one. So it's convert to GeoJSON, and like I said, if the user does not provide the output GeoJSON, it's going to return as a dictionary. So if output GeoJSON is none, that means the user does not provide. So you just return the GeoJSON, and that's exactly what we did here, right? So the user, we haven't tested the function in here yet, but we already know that we can get the GeoJSON from the shapefile. And so if the user does provide the GeoJSON or file path, also you're going to convert that one to an absolute file path, and then you're going to check the output directory, because sometimes the user can provide a directory that's has many labels, and some of those folders might not exist. So you want to make sure that, okay, if the user, they say if the user provide a file path like C, and then users, and then downloads, and then maybe a couple more labels down within this one, if the folder does not exist, when Python trying to write the file, it's going to throw an error. So you want to use that, okay, if the directory does not exist, it's going to always don't make directories and then the output folder. So any folder that does not exist, it's going to create recursively, so that you can always make sure that the folder will exist. So this is very important when you are dealing with data or files on your computer. These are some of the common ones that you need to handle: whether the file exists or not, or whether the folder exists or not, and how many folders that do not exist within that file path. Then you can use this one to create a directory. And lastly, then this is where we're going to save the file back to save the GeoJSON to your computer. We're just going to create the GeoJSON, right? So output once you have the file path, and then the W means write. Open this one and then write all the content. So how we can write a dictionary to a file is basically use the JSON. So JSON.dumps parentheses, and this is the dictionary, so the Python dictionary. If you have this one, you can also JSON.load. It's basically to load a file and then load that one as a dictionary from a file. So very commonly used a function in reading and writing Python dictionary. So make sure that you understand this portion. And so this function essentially is just convert a shapefile to GeoJSON. That's it. Once you figure out, then we can add another small function to the map class so that we can add the shapefile directly to the map. Assume that we have finished this function, then how we can test the function. Okay, let me go back to the notebook here, and this time we need to restart and create the output. And so once we have this, we can just execute Alt Enter, because we're just going to convert on a shapefile to GeoJSON, and we don't really need to create a map yet. So in this case, I'm just going to use the same shapefile that I use, right? So I can maybe maybe copy this one here up here, and then Alt Enter, execute this one. So next we can call the function. There are two ways, like you can either provide the output GeoJSON or you can just keep it as it is. So if we don't provide, then we can just call geo demo and then dot. Okay, so the function is called shp. Just hit type sh and then hit tab. It's autocomplete, and then parentheses shift tab. Okay, if you hit shift tab, you should be able to see the function definition. The first parameter is in shape, right? So it's this one that we provide in here, and the next one, this one is not required. So all we need to do is just copy this one, paste in here, then Alt Enter. Let's see, right? So Alt Enter, if you don't provide, it's going to return as a dictionary. Then you can use this dictionary to add that one to the map. Okay, so again, we can maybe put like GeoJSON equal to, if you assign this one to the variable, it's not going to print the output. If you don't assign, it's going to print out the output. So next we can just execute, create the map. Lastly, you can add the GeoJSON to the map. So m.add layer, right? And then GeoJSON. Alt Enter. Oh, you need to we need a few more steps. So this one actually is not add layer, it's add using the function that we create last time, add GeoJSON. And then this one, the first one should be the input GeoJSON, right? So you'll be the file name is called variable name is called GeoJSON. Okay, so this is how we actually add the GeoJSON to the map. But as you can see, there are two steps in here, right? So if we want to add that one to the map, we need to convert this one as a GeoJSON, and then you add the GeoJSON to the map. Similarly, in here, if I provide something, okay, so if I provide, then you don't need to assign this one to a variable. I can add another one here. I may make the output GeoJSON equal to, again, I can use double quotes and then the relative file path data, and I can say maybe countries, yes, UNTRES, JSON or whatever, dot GeoJSON. So the file extension can be either JSON or GeoJSON, and shift enter, then we can provide in here just out GeoJSON. Okay, then you can just hit shift enter, execute. Then we can go back to the Windows directory and we can take a look where we can find this one. Not to be under examples, data, this one, right? So this is the new one just created, countries JSON.GeoJSON. If you want, you can go to Visual Studio Code and then open the data. So if you see like U, that means unstaged yet. So that one has not been checked in the VS Code yet. So if you look at the source code, this is actually a dictionary. It's very long because it has a lot of points, vertices for those polygons. Okay, so once we export this one, then you can similarly you can add that one to the map if you want. So you can add GeoJSON, and then for this one, you can just pass in the out GeoJSON. It should be fine as well. So for example, out GeoJSON, and then you can maybe have a name, a layer name equal to you can say maybe second GeoJSON. Okay, it's going to be the same. but it overlay on top of the first one, so it get a lot darker, but you can turn the other layers off. This is the one that we just added, right? Yeah. And so this is how you actually can develop a function and then also test the function using Jupyter Notebook. So next, I'm going to show you how you can make life a little bit easier by creating a function that can use one line of code to add a shapefile to the map. So let's go back to here, and since we are trying to add something to the map, and that if we want to try to define another function, that function must be defined within the map class. So in that case, we need to have that indented within here. So that we unhide this one and then enter. Make sure that for each function you want to have one empty line in between. So once you have it here, you need to backspace, right, to move to up one more level, and then you just type def. In this function, we are trying to add a shapefile to the map, so we can maybe name the function called add shapefile or add SSP, whatever you want. And so the first one here, because this is the function within the map class, you always need to put the first one as a self. Okay, so self and then comma. So what do you need to provide if the user wants to add a shapefile to the map? Definitely you need to have an input, for example, shapefile, and the user provide a shapefile, but they can also have some parameters. They are going to have very similar like this one. So actually you can just copy, maybe copy this and then paste in this function here, right? At the end, colon, hit enter. And this is where you can actually add functionality. So keep it in mind, what we need in order to add a shapefile to the map, right? As I showed you earlier, you need to convert that one to a GeoJSON and then add the GeoJSON to the map. So this is kind of a two-step process. The first step is to convert the GeoJSON. If we want, we can actually do it in here. So we just need to call this function, right? Because if the user wants to add a shapefile to the map, they don't really need to output the GeoJSON. So in that case, we just need to call this function and we don't need to provide this one. So it'll be very simple. We can maybe create a variable name called GeoJSON equal to. So we are going to call this function and inside you just provide the parameter. So this will be the same one going to pass in here. And once we have the GeoJSON, we can self, like, so the self represent the map. Once you create the map, it can be m, it can be n, it can be anything. So the self represent that object, and then just add GeoJSON. Okay, so within here, the first one here, the name is actually called GeoJSON. Okay, and you can just paste in this one, comma. So for the GeoJSON, we can provide two additional parameters, the layer name and also the style. So when the user does not provide the style, it's going to use the default one. But what we need to do here is to pass in the style to the next one. So it will be style equal to style. Okay, very important. This is different. This one is different from the next one. This one. So this one is basically come from here, and this style is actually belongs to the name of the parameter. So what you need to provide is actually come from here. So this one pass into here, passing into here, and then pass into here, and then call this function. So last one will be layer name equal to, it will be layer name. Okay, but since we only have 3 parameters, you don't really need to put this one, but just for make it clear so you know exactly where those come from. Again, the layer here comes pass into this one, it's actually this one, and then pass into here, and then call this function, call the function above to add the GeoJSON. Okay, so and this one is relatively simple. It only has 2 lines of code. So once we have this, then we can start testing the function. Again, just hit Control S to save the file, and then we can come back to Jupyter Notebook. You always need to restart and clear output, otherwise it won't work because the function has not been loaded yet. And so now we have the function we need to execute, and just define the input file path, right? So now we don't really need this line. We can just delete. Next, let's create an interactive map, right? Once we have the map, then we can use the function. So what we need to do here is to use m.add, right? So you can just type add, hit tab, you should be able to find this one. So this is the function that we need, right? And the first one here, shift tab. If you don't remember the parameter names, the first one is input shapefile, and this is the variable here. You can directly pass in, and we're just going to pass in SSP. Next one, comma. So the style, we don't really want to provide a style, but you can always provide a layer name. And then double quotes. I'm just going to call this one shapefile, and then Alt Enter, and take a look. It's here. All right, so this is what we want. Now the user only need one line of code, then they can add a shapefile to the map without having to provide anything. Compared to the testing that we did earlier, right? You need to import the library, you need to read the shapefile, and then need to convert to GeoJSON. So now behind the scene, you actually make life easier for other people, and this is how you can actually build a package. And that's the reason that why you want to build a package, is to make life easier for yourself and also for other people, so that people don't need to write many lines of code, but they can do a lot of cool stuff. And let me go back in here. So once we add these functions, you can test more functionality if you want, but this is how you can actually add stuff to the map. And so let's create an example so that we can later push this example to GitHub. But I want to show you that you can clean up a little bit. Maybe I can put this one down here and add a new line, and in here, because if you want to develop some tutorials, you need to actually have a clean notebook so that other people can use it just like what you are doing in here. So in this example, we use two functions. The first one is add a shapefile, the other one is add GeoJSON. So let me add this one here, and also in here. And for others, I can just delete if I don't want to. Also, you can set the style. So in your notebook example, if you want the user to be able to customize the file, you can also maybe provide this one as an example. So I'm going to hit A on your keyboard to add a new cell block, and then from here you can add this one to the map. So for example, if you want, you can just put 0, 0. So this would be the fill color will be black, right? And then once you have this one, I can pass in here. So style equal to style. So this style comes from here, and this one is just the parameter name, and you need to use exactly the same. But for this one, you can choose to maybe st, and then this one also use st. It doesn't matter. Make sure you use comma, okay? And then we can maybe restart and make sure that the notebook works as expected. Then I can XX to the other non extension one, and I can maybe also change the layer name to GeoJSON. Okay, so now let's execute line by line. Okay, import the library, create a map, and then we're trying to add a GeoJSON or shapefile to the map, but we also want to provide the style so that the user can customize. Okay, enter, then execute. Good. What happened? Oh, it's here, right? So now because we use the black color, and then the transparency is like 0.1, but you can, if you change this one maybe to 1, it's going to be completely opaque. If you execute this one more time, it's going to completely black, but you really don't want that. So let's go back to 0.4 just to show you the differences. You might need to recreate the map, because the early one, once you add that one, the layer is always there. Right, so this is the first one, and then you can click the layer control to turn this one on and off. The next one is the GeoJSON. So we also want to test this function, run, and then run. You should also be able to see, sometimes in out GeoJSON. Okay, so it's basically in GeoJSON, not out GeoJSON. Run again. Okay, so it's being added. By default, it's going to use the default color if we don't provide in here. If you provide this one, you can also style equal to style. and then this is the GeoJSON. The first one is a shapefile, right? So now you can easily add data to the map using ipyleaflet. The example that I'm showing here is just a simple demo, and just to showing you how to add functionality to a module. So you can add within the map class, make sure that they're all using the same indentation, right? So it will be def, def, and then df. So those three functions belong to the map class. If something is outside, so the indentation is at the top level, it's going to it does not belong to the map class. When you are developing a package, always keep in mind what kind of functions do you want to associate it with a map class, and what kind of functions do you want them to be independent. So if you want them to be independent, they don't need the indentation, but anything that depends on the map class you want to put inside. So now we have this kind of three functions that we have some basic functionality that we add to the map. So next, I'm going to show you how you can actually push this to GitHub. So there are a couple of steps that you need to do. First, take a look at this one, see what kind of files have been added. And so some of the files you don't really want them. For example, this is some of the data that are converted temporarily. You can just discard changes, just delete the file. And then also this one, we don't really need the output JSON that we converted. What we really want is the file, the Python file, because we edited this one. This one is absolutely required. Also the output, the GeoJSON example, but it's untitled, so we want to go back to here, maybe to change this one to something more meaningful. We can maybe call it as a add shapefile, for example, and then rename. Also, after you actually know the example, it's better to just clear everything, because this is going to take some space. You don't really need it. Just restart, clear all the output, then you can save this one. So this one is just a txt, so it doesn't include any other object or images, so it will be much smaller. And so once you have this, you can just close them if you want. Next step, once you have added those files, you will see here we have 4 changes, right? So the first one are requirements, and also this is the new one we just added. Also the geo intro. Actually, we don't need to make changes. You can just discard changes. Okay, don't discard changes for other one. You will lose all the changes. Okay, so be very careful. Close, close, close. So the next step is actually to modify the documentation website. All we need to do is just go to mkdocs, click this one, and then scroll down. So in here, we add actually another example. So make sure that you add this one to here, otherwise it won't show up on your website. So let me go back to the GeoDemo website and go to the repo. If you click this one here, now the notebook is not show up yet because we haven't pushed the changes. So all we need to do, come back to here and then enter this one, notebooks. It's better to just copy the file name, because sometimes you can have typo and then it's not going to show up on your website. So I'm just going to not even examples. Extract files, copy the file name, and then come back to here. And you can just paste the file name, Control S. Okay, so once you have this, then we can just type in here, open the terminal. So you can open the terminal from here, or click here and then terminal. First, we need to actually conda activate demo. Once you activate, you can mkdocs serve. Hit enter. So it's going to build the website, and this is very useful because you can test the function in your package. Let me see here. The relative file path to notebooks is included in everywhere, but it's not found in the documentation of files. Okay, this is good because the example is right now in the example folder. We actually need to have a copy actually also within the documents folder, otherwise it won't show up. So you will need to have the file copy and then go to the docs folder, because this is the website it's going to use, and you need to make sure that the notebook actually is located. So you need to actually have 2 copies of notebooks. Okay, so once it's included, I can click this one and take a look. Notebooks. Oh, this one because we just added, so we very important. We need to reopen. So go back to here, Control C to shut down, and then use your up arrow. Hit enter again. It should build the website again, and hopefully it will be shown correctly. So if you don't see any error message, that means it's a good sign. So hopefully the website will be built successfully. Also, you might want to maybe execute two. Sometimes this one is going to take a while, so if you don't really need this one, you can also comment out this one. So I can we can leave it as it is if it doesn't cause any troubles. So now we can come back to open the website again. Control enter. Now we open notebooks. Add shapefile, right? Click. Okay, so it has been successfully executed. That means all the files right now, all the notebook works as expected. So once we confirm that it works fine, then you can Control C. Okay, so once you Control C, look at the files in here. So these are the files that we have made changes. Then we're going to commit the changes to GitHub. So what we want is add a commit message. So we can just maybe edit shapefile and JSON function, for example, and then just Control enter. It's going to commit all the files. Then you go to here, just hit push. It's push all the changes to GitHub. Then we can come back to GitHub webpage, GeoDemo. Click the repo. You will see here everything is being built, right? So, and after this built successfully, then we can bump the version. Okay, because right now if you see the release here 0.03, that one does not include the function that we added. So if you want to release as a new version, so this is basically a life cycle. Once you create a package and there are some functionality, once you have a couple of new functionality, then you want to release this one to PyPI so that other people can actually test and use the functions. Okay, so let me go back to here to do it quickly. Again, use the terminal, right? So once you activate the contact environment, I can hit Control L to clear the output. So what we want to do here is actually to use a bump version, and we're just going to just patch, right? Because it's just a small release, and then just hit enter. Next, git push -- text. Because it basically increased the version number, and then just hit enter. It will show you that, okay, so right now the new tag is 0.04 because the early version is 0.03, and the next one is just git push. That's it. So these are the three commands that you want to remember: bump version, patch, or minor or major, and then git push -- text, and then git push. That's it. Then we can come back to here and take a look at this one again. You can see the commit history, right? Well, right now we have like bump version from 0.03 to 0.04. You can also click to take a look at the source code. What kind of lines have been changed, right? So from 0.03 to 0.04, similarly, and also some of the function, right? This is the earlier one that we added. Once you see this one, for example, all the changes have been successfully executed, and you see a green sign, that means everything passed successfully. Then you can go to the release again in here, and then click text, upper right here, create a release, right? And then just copy this one. I can maybe just add **, and then say new features. That means I added something new to here, colon. And you can preview the message if you want preview the text. And I'm going to show you here, for example, hyphen and then space, say edit a GeoJSON function, and then the other one, edit shapefile function, something like that. If you have more, you can certainly add more, but I'm just going to use this example and then just publish release. Once you click this one, GitHub is going to automatically release this one to PyPI. So if you click this one, you will show here, this is the right now a yellow sign. That means this is waiting to be executed. So hopefully everything will work successfully. You can also see this one, the documentation has been updated successfully. So what we can do, we can come back to here, click the website, and hopefully it's here. Not here yet. You need to refresh. Okay, so and it's here. Click, then you can download this one. The user will be able to install the package and also update, run this Jupyter notebook on their computer. So this is basically a life cycle, how you develop package, add functionality, add some examples, and bump the version, and then create a new release on GitHub, and then publish this one to PyPI. You can always take a look at here, for example, PyPI. It has been deployed automatically. So you can go to the web page and then click this one, PyPI. Right now it hasn't shown up yet, but if you click, you should be able to see the new version, right? 0.04, and then click the release history. It's just 1 minute ago because this is just being deployed earlier. Okay, so this is kind of a long video, but hopefully you learn something that how to develop an open source package, and all the life cycle. Some of the things that you need to use pretty much the same again and again, because this is basically just one step, right? You can continue to add functions and then commit the changes, add tutorials, and then make a new release. That's it. So next video, I'm going to show you how to add documentation. I hope to see you in the next video. Take care. Bye bye.